Math 3, Unit 1, Section 1. So a lot of this should be a review from Math 2. The first thing we have is slope-intercept form. And slope-intercept form is written in the form y equals mx plus b. Can you tell me what the m stands for? Anybody?
Slope.
Good. So m equals slope. And what is another way of explaining what slope is? Very good. Rise over run. And also we can say that it is the change in y over the change in x. And if you didn't know that anytime you see that triangle, that means change. Okay, so it's just an abbreviation instead of writing out the word. Okay, the next one we're going to talk about as well is point slope form. And this is point slope form of an equation. When you are writing out point slope form, you will need to know a point and also the slope. Pretty crazy, huh? Okay, so this y1 and x1 represent a point, so that's your point, x1, y1. And then m again represents your slope. Does anybody remember what domain means? Good. Domain is your x values. Also, we will refer to it as well as your input. Meaning like you're putting in a number, and that number that you put in is your domain. Your range is your, very good, y values. Also known as the, you guys are amazing. Okay, when we're writing our domain and range, most of the time in here we're going to be writing it in something called interval notation or interval form. When you're using interval form, if you have brackets like this, that means it's including the value. While parentheses do not include the value. I don't know if you remember yesterday from your pre-assessment, but you had, let's say you have this graph like this, okay? And on the graph it has an open circle going, you know, like this. If I were to write interval notation for this, okay? And so my domain is our x values. The x values start at what value is this right here? Well, this is the y, but on the x-axis, this is 0. So I would write this with a parenthesis and a 0. The reason why it's a parenthesis is this is an open circle at this value, okay? And so it doesn't include it. Where if I had a graph, we'll say like this, and it was a closed circle going like this, oops, thank you. I would end up for my domain writing it as a bracket in 0. Okay? Now, the next thing on your notes is that it says that when using interval form, always begin with the lowest value and end with the greatest value. For infinity or negative infinity, you will always use parentheses. Does anyone have any idea why we would use parentheses for infinity versus using a bracket?
Because infinity can contain anything besides the value that's given.
Very good. So infinity doesn't ever have an end, right? It goes on forever. And so that's why you have to use a parenthesis, because there is no specific end value where it's going to stop. And so you always use a bracket where you have a stopping value that's at a specific value. But infinity doesn't really have a specific end value, does it? So on this one, you would end up going 0 and then infinity, like that. And this one, same thing, would do a comma and a 0 with a parenthesis for infinity. And remember, if you have a hard time making infinity symbols, you can always turn your paper, make an 8, and then put it back. Okay. All right, so this is what we're talking about in terms of interval notation. So we're going to go ahead and move on to some examples here. Notice that you need to graph them and then also state the domain and range. When you're graphing in slope-intercept form, the two things you need to know is your slope, which is your M, and your y-intercept, which is your B. So on this first example, what is my slope? -3. And when we're doing slope, we always want it as a fraction because it's your change in y over your change in x. And so I can make any whole number into a fraction by putting it over
1.
Good job. And what is my y-intercept? Perfect. Okay, when you're graphing, you always plot your y-intercept first. So remember, this is our y-axis, and this is my x-axis. Just in case you've forgotten, going right is positive, left is negative, up is positive, down is negative. So if our y-intercept is -1, we will go where? Perfect, and make a point. From there, our slope is -3/1. So this is now my new starting point, wherever my y-intercept is, and I go down 1, 2, 3, and then right 1, and make my point. I'd also like you to get into the habit of doing the opposite, and so the negative can go with the 3 or the 1. So from this point, I want you to go back, and we're going to go up positive 1, 2, 3, and left 1. And then you can draw your line. If you want your lines to be perfect, you can use your ID card or borrow a ruler from me at any time during the lesson. If you want to go up and grab something, you can. Okay? All right, so the next thing we're talking about is domain and range. If you think about this line, when you have arrows going in both directions, that means that the line is going on forever. Okay? And so therefore, on the x-axis, even though we only see part of it, if you were to draw this line continuously, it would go on forever in the x direction and also forever in the y direction. So for most lines, and actually for all lines that have a slanted slope, your interval notation, your domain, is going to be -infinity to +infinity. And the same will be for your range, -infinity to +infinity. You might also hear this referred to as your domain is all real numbers. Okay? I'm going to write this down, all real numbers. There is an abbreviation for all real numbers. Do you guys know what that is? You draw two parallel lines like this, and then you put an R around them. And that stands for all real numbers. Okay? This would be an acceptable answer for domain and also for range, or our interval notation. But I'd like us to become more familiar with this, so I'm going to kind of stick to this in everything that I do. But on a multiple choice test, you know how sometimes they would ask you questions like which answers are correct? Well, you could choose this answer and this answer. Do you understand what I'm saying? Yes? Okay. All right. Next example, I'd like you to do that one on your own. Once you get your answer, make sure you write domain and range and check in your groups to see if you guys agree. Okay, so it's just like our first one. So I'll give you about 30 seconds. All right. Okay, so what is my slope on this problem? Good, 3/4. And my y-intercept is 2. What do we plot first? Very good. So I'm going to go up 2, make that point. From there, we're going to make our slope. So from here I go up 1, 2, 3, and then where? Which way? 1, 2, 3, 4. Okay, if I'm doing the opposite direction, where will I go? Good, down 3 and left 4. And I can do that because 2 negatives actually make a positive. Good. And then we draw our line. What will be my domain on this? Good, negative infinity to positive infinity. And same with my range. Questions? Okay. What do you notice is different about this next problem? It has parentheses. Good. What else? What would I need to do in order to be able to graph this? Very good. Distribute. So we're going to multiply negative 1/2 through here. And I get y equals negative 1/2 x. And negative 1/2 times 1 is negative 1/2. And then I have plus 3. Negative 1/2 plus 3. You have a fraction and a whole number. Some of you may be able to do this in your head, I think. Because a half is like 50 cents, right? Half a dollar. So if you have $3 and you take away a $0.50, how much do you have left? $2.50 or 2.5. Is that okay with everybody? All right. So that means that this equation will be y equals negative 1/2 x plus 2.5. Sometimes when you're like choosing a answer for a line, they might not have 2.5. They might change that into an improper fraction. Do you guys know how to change that into an improper fraction? Good. So I'm just going to write this here just so we have it. Y equals negative 1/2 x, and 2 times 2 is plus 1 makes 5, and then you keep it over whatever denominator you had, which is 2. Okay? So both of these equations are the same, but I think it's easier to graph 2.5 than it is to graph 5/2. So when we're graphing this, my slope is what? Negative 1/2. And my y-intercept is, I'm going to write as 2.5. Good. So how do you graph 2.5? Where do you go? So it's positive 2.5. So I'm going to go up 1, 2, and then just go a half. Anytime you have a fraction, it just means it's in between those two numbers. So 2.5 is in between 2 and 3. So you're just going to make a point that's in between 2 and 3. Now, to do this slope, I'm right here, and I'm just going to go down 1, which means I'm just still going to be in between the two lines. So I'm going down 1 and then right 1, 2. And this is where my point is. And then same thing if I start here, I'm going to go up 1, and it's still in the middle of the two lines, and then right 1, 2. And you can draw your line. Do we have questions on that? Okay, what's my domain on this? Good. Negative infinity to positive infinity. And the range? Good. Negative infinity to positive infinity. In your groups real quick, can you explain to each other why both of these are negative infinity to positive infinity?
you always do your like note guys. I like to write everything down. So you guys try to kind of
All right, so I didn't make it around to all the groups, but one thing to remember is that with your lines, okay, if you were to continuously draw it forever, it would end up hitting every x value. So x's are going like this, right? So even though, let's say your line's here, it's still at like a -2 on the x and something on the y. So what happens is as it extends, it'll end up having every x value and every y value on the graph as it goes to infinity. It's kind of hard to visualize sometimes, but hopefully that helps. Okay, what is different about our next example here? It doesn't have an x, it only has y equals 3. In your groups, talk about how you would graph y equals 3. See if you remember. So think about the information is there. What information is there? Okay, I hear some of you and you have a lot of good conversations going on. Okay, y equals 3. Where is y equals 3? Okay, up 3. So I'd always start with that, and then you're like, okay, how would I draw a line with that information? Very good. Straight across, because it's only going to hit y equals 3. If you made this line up and down, it would hit every single y value, right? And it's saying it can only equal y equals 3. Now this is where your domain and range are going to change. Notice that there isn't a slope on this. Okay, it's just a straight line. So starting with your domain, what is going to be your domain on this? Domain is your x values. Domain is your x values. Look at this line. It's hitting 0, it's hitting 1, 2, 3, 4. Because it's going right and left. Your domain is your x going right and left. It's going to hit, very good. So your domain is negative infinity to positive infinity. Now your range is a different story because it's not hitting every y value, is it? So what do you think your range is going to be?
0, 3.
Close. Well, it is 0, 3 is the specific point, but for your range, it's only 3. The only y value it's ever touching is 3. Because, you know, like this is 0, 3, 1, 3, 2, 3. So see how you get a whole bunch of x values, but the only value that you'll get for y is 3. No matter what x value you give it, you only get 3 for y. Okay, now that you know this, try to do x equals -4. And see if you can figure out the correct domain and range on that one. Okay, once you have it, talk in your groups, check with each other, see if you agree, if you don't have the same thing. How many of you think you got it right? Good. How many got proven wrong? Anybody? Okay. All right, so x equals -4. Remember, this is our x-axis, so we're going to go left 1, 2, 3, 4. Now, if I drew a line through this x-axis, I'd be hitting every single x point, correct? And so with an x equals value, we're going up and down for our line. What is my domain for that? Good. It is only -4. The only x value that is there is -4. And what will my range be? Good. Does anybody have questions on this or on either one of those problems? Yes. Well, it goes up and down like this, right? So it's going to go up and down infinity in both directions. Is that what your question is? Okay, so yeah, so if you were to do it like this, you know, Okay. All right, next example here. What do I need to do in order to graph this?
You need to get one of the variables by itself.
Good. We need to get y by itself, usually specifically, in order to graph, right? And so if I want y by itself, I need to start by getting rid of that x. So what would I do in order to get rid of that x? Very good, because whenever we have addition, we undo addition by subtraction. So x and negative x, those cancel. And so I'm left with, don't forget signs, negative 2y equals negative x plus 5.
Oops. Sorry.
Now, why did I write negative x and then 5? Because we want it to be in y equals mx plus b form, and so we'll always have our x first and then our number that's not an x last. Okay, what would I do now? Good. I personally go through and write negative 2 underneath every single term so that I don't forget. If you just divide the whole equation by negative 2 and you're good with that, that is fine with me. Okay, these cancel, and I'm left with y equals 2 negatives make a positive. Now, if there isn't a number in front of the x, what number's there? A 1. So I'm going to write this as 1/2 x. And a positive and a negative make a negative. So I have negative 5/2. This is an improper fraction. It could also be written as a mixed number. Do you guys remember how to change these into mixed numbers? How do I do it? You divide. You take the bottom number 2 and you divide it into the top number, which is 5. 2 goes into 5 how many times? 2 times. 2 times 2 is subtract 1 left over. And so I write this as 1 over, and whatever my dividing number is, that's the number that goes on the bottom of the fraction. So 5/2 is the same as 2.5. So this equation could also be written like that. Questions? All right, what is my slope is 1/2, positive, and then my y-intercept is negative 2.5. So where do I go to plot negative 2.5? Down 2, and then go in between 2 and 3, right? From there, I have to go up 1 and right 2, or down 1 and left 2. Wait, yeah, sorry. And we draw our line. Domain and range on this one? Good. Negative infinity and positive infinity for both of them. Also, just so you know, as we are doing notes, if you notice me make a math error, please call my attention to it. Anytime you find me doing a math error, you get a candy. So, reward you for finding those mistakes. So please don't be afraid to tell me. All right, moving on. Are we ready? Yes? Okay. All right, so transformations are different ways of moving figures. Translation means that you're shifting it around. A reflection is when you're reflecting it across like the x-axis or y-axis or a specific value. Rotation is when you're turning the figure, right? And does anybody know what dilation is?
Bigger.
Making it like bigger or smaller. We aren't going to do too much with that, maybe nothing at all, but just so you know, there are actually 4 different types of transformations. Okay, so with translations, which we're going to mainly focus on here, whatever's with f of x here, this is dealing like with the x value, okay? Where the end part is always dealing with the y. And so when it says that you're adding c here, this part is dealing with the y, okay? When you're shifting. And so if it's saying add c, how do you think I'm going to shift it? I'm going to move it c units either up, down, left, or right. Up or down. And so when it's adding c, you're going to be shifting it up. Which means if you're subtracting c, you're going to be shifting it down. Okay, good. Now, anything that's with the x is actually going to be shifting it with the x. And x is going left and right, correct? These, though, whenever you have something in parentheses, you normally end up setting it equal to 0. So if I had, let's say, x plus 3, and I set x plus 3 equal to 0, in order to solve for that, I would subtract 3 and end up getting x equals negative 3. Do you guys agree? So while it looks like sometimes we think that we would want to go right, whatever's in parentheses ends up being the opposite. So if you're going to add c, you're actually going to end up moving it left. And when you subtract c, you're going to end up moving that one right. And I'll kind of show you how that works out in one of these equations so you can see it visually here in a minute. When you're doing these graphs, you can either label these like as A and B or 1 and 2. I'm going to do 1 and 2. So this is going to be my number 1 graph, and this is going to be my number 2 graph, because you're going to put 2 graphs on the same grid. Okay? Now, when you see f of x, that is the same thing as y. So you can think of this as y equals 1/2 x. When I'm graphing that, my slope is what? 1/2, and my y-intercept is 0. How do I know it's 0? Well, there's nothing added at the end, therefore it's 0. Good. So we plot a point at 0, and from there, I'm going to use my slope and go up 1, right 2, or down 1 and left 2. And we'll go ahead and draw this line, and I'm going to label this as number 1. Now, what am I going to do on this shifting? So when we have f of x minus 2, how am I going to shift that? What am I going to do? Down how many? Down 2. So if you look at these points, you're going to go for each point and you're going to go down 2. 1, 2, 2, 2. And we're going to draw a line, and I'm going to label that as number 2. You do not have to do this in your homework tonight, just so you know, but I just want to show you how this works with this equation. So if I were writing this equation, I would write it as f of x equals 1/2 x, and then it had a plus 0 here originally, right? And so I'd end up going 0 minus 2, which gives me negative 2. So my second equation line is this, and you can double check it, and if you see it goes down 2, made a point, and it goes up 1 over 2. So you can see how that works out. Okay, so let's go to this other problem with g of x. So again, this will be my number 1 graph, and this will be my number 2. So starting with the number 1, what is my slope? Very good. And my y-intercept is negative 2. So we're going to go down 2, make a point, and from there I'm going to go up 1, 2, 3, right 1, or down 1, 2, 3, and left 1. And that is number 1. G of x plus 2. So notice how the x plus 2, x plus 1. Notice how this is in parentheses. So going back here, where am I going to end up shifting it? To the left, how many? Left 1. So I can go to each of these points, and I'm just going to go left 1. And I'm going to show you mathematically how this works. So this x plus 1, this gets put in for x into this equation. So if I were writing this, g of x equals, and I'd write this as 3 times x plus 1 minus 2. Okay, we would distribute this, and I get 3x plus 3 minus 2, and I get 3x plus 1. So my g of x equation is 3x plus 1. And if we check that, see how this went up 1? And then the slope is up 3, right 1, or it could be down 1, 2, 3, left 1. And see how it works out? Okay. Do we have any questions on this? Okay, this next part, they want you to write the linear equation for the given graphs. So let's see if you guys can remember, how would you write that equation for that line?
X equal 1.
Very good. X equals 1 is correct. There's not any other way of writing that one. X equals 1 is your answer. Okay, they didn't tell us specifically what way to write these lines. Okay, and so on this one, if we were just to write it in y equals mx plus b form, slope-intercept form, we would need to know our m. And so how could I find my slope? Count. Good. So it's up 1, 2, left 1. So how do I write that? 2 over negative 1, which is really negative 2. Are we okay with that? And what is my y-intercept? Negative 1. So write that equation on your own. And you should have got y equals negative 2x minus 1. Are we okay? All right, this last one, they told us specifically to write it in point slope form. So you need to pay attention to that. Point slope form, you need to know your m value, and you also need to know a point. Okay, so finding our slope, we have these 2 points and we can find our slope, and it looks like it's 1, 2, 3, 4 for the rise. 1, 2, 3, 4, 5, 6 for a run. And what does that reduce to?
3.
Very good, 2/3. So we know our slope. For the points, you need to write the specific points that they have on the graph. So what is this specific point as an ordered pair? Good, negative 2, negative 1. And what is this ordered pair? 4, 3. Okay, there we go. So I'm going to write it in point slope form for one of them, and then I'm going to have you write it for the other one. Either answer is correct. If you were to simplify it, you would get the same y equals mx plus b equation, but point slope equations can look different. So we write this as, and you might want to label x and y for these. So our point slope equation, it was back on the beginning of the notes, y minus y1 equals m times x minus x1. So when I write this equation, I will write it as y minus, and let's use this first point here, y minus negative 1. Well, what happens when you have two negatives side by side? Good, it makes a plus, equals my m is 2/3, and then I have x minus, and my x value is negative 2. And again, two negatives end up making a positive. Okay, so that is one equation. Or we could have used this point. So I'm going to give you about 20 seconds to write the equation using the second point. Okay, so using that same formula, you would write this as y minus what? 3 equals 2/3 x minus 4. Okay, so it's always minus, but then you have minus and negative makes a positive. So you don't need to do 2 equations on your homework, just one, but I wanted you to see how it could be 2 different answers. Are there any questions?